This is our basic functionality. User can type desired town or postcode, and our map will render a selected location, and our application will return average sold price for houses in this area.
Cool. The next thing we'd like to show off is the heat map. So when the user clicks the heat map, it will render using the coordinates from our server, the average house prices for each point. The user can zoom in as much as they want and get granular information for a local area. The redder the spot, the higher the house prices are. This is calculated using a weight which is also stored inside the database. We stored it inside our database like that, and it loads into Heroku to make sure it's really smooth.
Cool. This is our charts that we're going to show. So the user enters in a town or a city, and we show the average price updated, and then you can see the average price for each type of property type. So it's quite interactive. You can turn them on or off, or you can, as you can see here, and only show what you want to display, and then also show the local crime data in the area as well. When I chose to do different types of charts just so it's easy for you to visualize and understand rather than just statistics on a page. And the next thing is showing like the local broadband speed in each area. I chose a bar chart because it's easy to show like the highest speed in that area. And also the average house prices in the UK. So you can overlay like Scotland, England, Wales on top of each other, and you can see like the ranges of each property type.
So once a user has chosen an area, this is Federation House over here, Google provides a number of other layers you can use, such as cycle routes or public transport locations and traffic density. There's an option for custom layers, so we used another data source and imported some additional data in order to do county boundaries, which can go on there, and then you can just overlay whatever kind of custom data you want to do on the map. I wanted to make sure it had a mobile-friendly layout, so it's quite white, not much text. I use Chrome resizing, but I also like Screenfly. You can adjust it to various devices with a 13-inch notebook, Kindle Fire, and then you can see how it looks on an iPhone 5 as well. There's some of the divs needed to move position, or at least appear to the user, so I read up on best practices and I rendered all the divs at once, and then they show and hide based on the resolution that the user is using.
The next thing is just something simple, just gives an overview of our application. So when the user accesses our web application, makes a query, it calls to the server application down here. Then the server application will interact with the database, send it back to the server application and into the user web application. If these are coordinates, for example, the coordinates we stored in the user application, which will then be passed into the Google API and render the map completely.
So the tech choices we used was, for the front end, we used React because it's very simple and lightweight library that only deals with the view layer, has reusable components, fast render with virtual DOM, and when given user input, React can dynamically change the coordinates in the Google map and update the average price on the application. It was styled in CSS and Flexbox to allow for responsive layouts for mobile and tablet. Used Chart.js because it was a library which had really good documentation compared to all the other ones that I was trying to figure out how to use, which allowed me to spend more time on actually playing around with the design and the style of it rather than just trying to make it work with React. For the back end, we used MongoDB because it's better suited for large volumes of data. It's fast and efficient, and we assumed it would require minimal relationship between collections. We used Mongoose, makes returning updated documents or query results easier. MLab for hosting database in the cloud. Express because it's a lightweight framework. Heroku was ideal for rapidly prototyping our project. With little configuration, we were able to upload our application to Heroku on the third day. This allowed front end to make calls to the application without having to run a local version. In addition, we tied Heroku to our GitHub so it would automatically build from the latest master. This allowed us to change the API quickly for the front end team. And GitHub because it's easy to share permissions to the rest of the team and work collaboratively.